Hi, I'm Jon Woodard with Wolfram Blockchain Labs. We're a new subsidiary of Wolfram Research. We work on a lot of the blockchain related items. And at WTC in 2019, I'm talking about our education and research initiatives. Mainly, that's about an introductory blockchain MOOC that talks about both the economic issues, issues around society, and issues around the technology of blockchain and accompanying technologies. In addition, we have another project, World of Blockchains. It's dealing with collecting different attributes on blockchains around the now like hundreds of blockchains that are out there to prove useful for people to search through and look and kind of discover the ones that are most useful for their projects. I'm Jon Woodard, and I'm going to be covering research and education initiatives in, I think it was blockchain in there, but I kind of changed that a little bit to decentralized technologies. So first, I really wanted to give an outline of why it might be interesting to learn about blockchain and decentralized technologies. We have a couple of things that we're working on, an introductory course, along with collecting all the various DLTs that are out there, along with their attributes. And so that's that decentralized project data. Then I'll talk a little bit about kind of the future and what distributed ledger technologies might enable in terms of autonomous sort of projects. So a little bit about Wolfram Blockchain Labs. We started as far as, I think, collecting and using blockchain-related stuff with Wolfram Alpha in like maybe 2014 in terms of adding prices. That's also available in currency convert as a Wolfram language function. Later on, we added an instance of multi-chain, which is a permissioned ledger, which is also accessible via Wolfram language. And then we started adding additional public blockchains, Bitcoin, Ethereum, Arc, and we're working on others there. We also, since I think around 2014, have been used with lots of decentralized services as actually an oracle, where people use data from Wolfram Alpha to enable operational clauses in smart contracts. So that's how folks have been using this now. And with Wolfram Blockchain Labs, we kind of collected all those projects around Wolfram Research into one entity. I thought I'd mention a little bit about the Wolfram Blockchain Labs team. We have a number of engineers. We also have a cryptographer and an economist. So, and then myself as sort of a business person. So we have a real interdisciplinary team, which is really helpful for blockchain because there's so many different topics that come up in terms of using it. In fact, I think Christian Pascal, who's on here, kind of characterized blockchains as kind of new economic societies. And that's something really interesting and useful to think about because they're trying to organize economic activity. And that's sort of both the sort of the currency aspect along with the public blockchains to record that activity. So I wanted to go into a bit of history. You'll notice this talk is far more about research and collecting so we understand what technologies are out there and are important than the actual technology itself. I think Akira and Piero are giving a talk right after lunch that will go more into our initiatives actually integrating technology into Wolfram language. So this is kind of like an informal web eras in a way. The zero sort of era is like research and the non-commercial web with ARPANET sort of starting, then getting the go-ahead in around maybe 95 to commercialize and having that first burst of commercial services. Some of those still exist, Amazon, eBay, others. Then Web 2, kind of the participatory web, a lot around social. So I think a lot of people characterize Flickr and that as a service. It was a photo service where people could upload their own photos, they could do comments. We kind of had blogs and other stuff in this area. So it was really kind of this democratization of the web in many ways. There's also this sort of growth of semantic and machine readable data. Some folks kind of call that maybe Web 3. I like to call it Web 2 because a lot of people in this decentralized era characterize that as Web 3. So that's this era where Bitcoin kind of kicks it off, but in many ways, Bitcoin and what Satoshi Nakamoto was able to do actually was a long progression of people kind of, in many ways, turned off by, I guess, the commercialization of the web. There was this, there was this cypherpunk mailing list, which was this combination of cypher and punk to come up with the cypherpunk idea. And really, I would say like the core idea behind that was taking cryptography to provide secrecy and privacy for users, to really kind of try to make this promise that a lot of people thought of with Web sort of 0 possible for average people, that they would be able to have secure communications without kind of the prying eyes, in a way, looking at their communications. And so Nakamoto, in many ways, took this idea with Bitcoin as a peer-to-peer electronic cash system and took all of these ideas into a new system. And that goes back to talking about this as kind of this new society, in a way. So one of the kind of interesting concepts in looking again at those eras of web growth is an idea of an economist, Joseph Schumpeter, talking about creative destruction. And that's kind of that in capitalism you have old ideas, old products that will be kind of destroyed by upcoming new technologies and new ideas. Clayton Christensen actually has another sort of slight version of that you hear a lot about, and that's disruption. Clayton Christensen's idea is that it's kind of, you have existing services that add features, and they're kind of disrupted by newer, cheaper services. And often that happens with changes in technology that incumbents aren't able to really deal with. When it comes to sort of decentralized technologies, and this is why I kind of included that in the title rather than blockchain. Distributed ledger technologies or blockchains, acyclic graphs, and other sort of things. There's no clear sort of definition. Some people want certain attributes to always be included, other people don't. And then there are decentralized services or layer 2 services like identity services, file services. I think last night Stephen talked about our connection to IPFS or Interplanetary File System, which is a decentralized file storage system. So this is just this idea, huge change, that maybe this 10% GDP will happen. I don't know if that's really accurate by World Economic Forum. But it does have the ability to affect a lot of different services that are out there. I think in particular, because it's this newer technology, that developing countries may reimagine and build services solely using more distributed projects. Like we kind of see with going from telephone services and not being able to lay copper wire actually because of corruption and people just stealing the wire, to being able to have mobile services and really getting a leap ahead of existing technologies. It could be the same case when it comes to consumer services, government services, and even as money, in particular when it comes to developing economies. And so that might allow them to be more efficient and kind of actually leapfrog ahead. When it comes to Wolfram Blockchain Labs and our approach to these technologies, you'll hear from Akira and Piero after lunch. As far as the integrations that we've done, that's like with Bitcoin, Ethereum, Arc, and others, and computational facts. I think Stephen talked a little bit about that last night. Now for really this topic is more about this education and research. One, we're creating this introductory blockchain course, which I think a lot of people have questions about. Whether the technology will be interesting and useful in other ways beyond this idea of Bitcoin and digital currency. So it's really talking about that. And then also this world of blockchains, which is trying to collect all these different projects that are out there and then collect attributes on their blockchains, both in terms of the technology and the protocols that they've created, but then also in terms of the activity on the blockchains themselves. Again, going back to the fact that they're kind of creating these communities. The course really focuses on, actually history of money shouldn't be like all these things are under it, but understanding modern money and the changes and kind of money as a technology, that it's changed broadly over time. Also, the governance of public networks that are out there, like Bitcoin, like Ethereum, you have people who are making changes based on votes and things that they've kind of created. So it has to do not only with the technology, but it's also behavioral. Economics, politics and social structure, again, because they're behavioral aspects of this, and that people are kind of creating these communities. So this is a reimagining of Paul Baran's illustration of nodes, using it for communication networks. It's done actually in Wolfram language. And he had this idea, I think, during the Cold War, where we're trying to figure out, okay, well, what kind of communication system would actually survive like a nuclear event? And the idea was this distributed network would do just that, with equal nodes and nodes that were capable of communicating with each other. And this is something that a lot of decentralized projects have taken to note. That's why we kind of include it here, is that this is kind of the system that they're trying to design. So one of the interesting things with all of these different systems and how people have built kind of distributed networks over time is that there's different ways of kind of characterizing what kind of a blockchain is and what a community around a blockchain might be. Napster is kind of an early thing where it was centralized, and then you had things like, because Napster was centralized as a somewhat distributed network, it did have centralized servers, people were able to attack it. So you had Kazaa come with, that was more decentralized, where there were peer-to-peer systems. And that made it harder to actually take down Kazaa, and it became this huge file sharing system. So you kind of see the same with how people are developing and designing blockchain public networks. We have Ripple kind of there as an example. Again, like it's kind of a centralized blockchain. And there are also other ways to think about blockchains in terms of like how they'll support copyright, how they'll think about actual law and jurisdiction and other stuff. So it's kind of trying to rank those. So anytime we talk about distributed ledgers or blockchains, it's kind of maybe useful to think of a basic kind of example of this kind of progression. And we do that, of course, in the MOOC kind of multiple times. We build it up from kind of a very basic explanation to kind of a toy example that's actually using Wolfram language that isn't as sophisticated naturally as like Bitcoin or Ethereum, but kind of gives people the flavor of the cryptography that's used. And then go to a full examination of Nakamoto's paper, but not really in super detail, at a high enough level that people can get a lot out of it without kind of going into code. So one of the things that I think about, and the reason why I usually like to talk about blockchains as being distributed ledgers, is that it really comes from this idea of a ledger. And kind of in this case, it's this old accounting ledger where you can enter in transactions and you have like one canonical ledger. And you can kind of see how that might be difficult and problematic if someone were going to, say, cheat this ledger. They might have one public-facing book where they're entering in transactions, and then have another book kind of under the table that they're manipulating the transactions with. And if you only have access to the public-facing book, you'd be in trouble. You can also think about that as well, that the person who really controls a ledger kind of controls everything in a way. And the idea, and people went from this paper ledger, of course, to digital centralized ledgers. And the idea with, the way I think about Nakamoto and really kind of the brilliance behind taking all of these services and ideas from the cypherpunk mailing list and building it into Bitcoin as a peer-to-peer electronic cash is that it's the idea of liberating people from this centralized system. So rather than a central banker having this ledger where they are printing money, you have a community where anyone who wants to and has the capability could run a node. And with those nodes, these transactions where one person would be entering them in on this ledger, you can give your transaction to a node. The node can give it to the min pool. When someone solves a cryptographic problem and has the right to add a new block, they'll collect those transactions and add them to the blockchain. So it's kind of, in a way, trying to take power from the centralized ledger folks, whatever that centralized organization might be, and kind of distribute that in a community where everyone could run a node. So that's kind of a brief talk about the technology kind of aspect. One of the things that we found and really like as a theme in the course is actually money as technology as well. So early, people starting with tokens and kind of the high priest kind of having control of these tokens and control of defining what money is and being able to have control over contracts as well and how those contracts would be executed, to now maybe some of those powers entrusted in the governments and central banks, having control again of the money supply and how laws will be interpreted and executed, to maybe this, which is the Facebook Libra logo, which if you've seen any of the things recently, they're getting a lot of heat over trying to kind of take this control of what money is and in issuing money from central bankers, which has made them very, very nervous. Because it'd basically be taking away monetary policy or tools of monetary policy. Let me see. So this is an interesting Venn diagram of this money flower by Beck and Grot. And it's kind of this idea of trying to look at these different currencies that folks are using and are issued issued. It's kind of a tautology of money. And we're trying to explore and sort of categorize the things that exist that are out there. So that's kind of where this blockchain MOOC kind of ends, where, again, we're trying to explore both the technology, and we're using Wolfram language a lot for that, along with the great tools from Wolfram U folks. That aspect, along with the economics and social aspects, to really give people a lot of insight into how these things are going to be used and how they've influenced things beyond just Bitcoin. Because I think a lot of central bankers at first were sort of contemptuous of Bitcoin and thought about it as being a joke. But if you look at Bitcoin kind of influencing other digital currencies, namely like Telegram, which has something that's out there that has kind of gone under the radar, to Facebook's Libra, which people certainly take very seriously, and China in terms of coming out with a digital renminbi soon. Like, this has had an awful lot of influence. So the technologies themselves are also having a lot of influence. So The other sort of project, again, is like collecting these DLTs, trying to get an idea of how many are out there. I haven't really made this interactive, but does anyone have a guess about how many DLTs there might be out there, public DLTs?
5,000.
5,000? Nope, way too high. Well, maybe, I don't know. But what we've been able to find is about 400. And I should have actually included permission ones as well, although there's a very small number. Just some examples, there's like multi-chain that we use. There are public ones that we have integrated, Bitcoin, Ethereum, Arc. Vertical kind of applications, I would say like coins. Ones that are like specific to things like games, and then agreements, which are like smart contracts and other stuff. So the thing here is that I actually overheard a conversation earlier was like, oh, you know, Bitcoin can only support like maybe 7 transactions. That's not useful enough yet. Yes, that's true with Bitcoin. There are other sort of blockchains that are public networks that are out there that claim to support more transactions. Of course, that doesn't really matter if you don't have the transactions where people are using it. But the goal of this project is to really not only collect the DLTs that are out there, but collect attributes about them, both the static attributes. I actually think I have another slide here. Both the static things like the consensus methods that they use, their first sort of block or genesis block, which really tells you when they initiated as a public network, the founders, and then computable things, you know, what we love at Wolfram. The average transactions that they have in a block, who cares if you can support 10,000 and you only have 2 in a block. And then things like the average transfer amounts to kind of see, again, the economic activity that's taking place. Oh, let me say a little bit about proof of work and proof of stake. Proof of work is what Bitcoin uses as a consensus method. So it's just computational power. One of the things that's interesting there is that I think for Bitcoin as a public blockchain, it takes about the power resources of, I think, like Denmark, which is kind of daunting. Because you would see if this scales an order of magnitude, like that's a lot of resources going to essentially nothing. Proof of stake is another sort of way where people either do it on the basis of how much of the token you actually hold, and they do like a lottery. The more you hold, the greater probability that you'll get the right to determine the next block. So lastly, I wanted to talk a little bit about the autonomous future, because this to me is like the most interesting part, and it has more to do with the technology than the kind of the cryptocurrency and cryptocurrency kind of bubble around, you know, Bitcoin being worth whatever. It's more the technologies themselves. So I got this from the folks at McKinsey, but I like it because, you know, we could have all of these things out here that behave in this kind of autonomous or semi-autonomous fashion, whether it's the cars, people on phones doing contracts, Internet of Things kind of communicating, and really thinking about like smart contracts and computational contracts. All of these things need sort of data, which we absolutely have at Wolfram, along with computational contracts that we're kind of developing. Because in this world, we could imagine where cars are kind of autonomous, and maybe you're in the situation where you need to go somewhere really fast, and now cars are way safer, so you can pay people to pass them on the interstate. Well, all of those things are going to be contracts. You're going to need to have them behave in an autonomous fashion. You're not going to want to, you know, click pay to pass people. So I think that kind of gives an idea of how these technologies might be used in the future for the good of humanity in many ways, beyond just this idea of whether these currencies will kind of have staying power, which, you know, I'm not really so sure about. So that's the end. Any questions?